Hello, good day to everybody. Mingalaba. So we are from Clickstop Engineering Myanmar, and we are offering open lectures. And the lectures I'm offering is mechanics subject. And for those of you who are watching for the first time, we do mechanics because it is one of the important foundation for engineering and science students. And of course, those of you who are sitting for international A-level test. So we have already covered a lot of topics, and in the previous videos we did the projectile motion theory and one of the examples, and today we are also looking at another example from the textbook. And the textbook that we are using is from Pearson Edexcel International Further Mechanics 2, and we are already in example 2 of the chapter 1, and of course we will do more examples and exercises in the next video, so please subscribe to our channel. And now today let's look at the problem that we are covering in this video. So let's just try to read the problem first. A particle is projected horizontally with a velocity of 15 meters per second. So your object is projected just horizontally, so this means the initial velocity in the x direction is 15 meters per second, and y direction is 0 because it just projected horizontally. And now you are asked to find the horizontal and vertical components of the displacement of the particle from the point of projection after 3 seconds. So after time t is equal to 3 seconds, you are asked to find the horizontal displacement and the vertical components of the displacement. And B, the distance of the particle from the point of projection after 3 seconds. So those are the basic quantity that has been asked in the problem. And right, so now let's look at with the sketch. So if you look at this sketch, at time t is equal to 0, your object is here, and then it's just projected horizontally. So this means initial velocity will be only x component, there will be no y initial velocity. And after the object is projected, and of course object will free fall in the y direction and move to the right in the x direction. And then after time t is equal to 3 seconds, you are asked to find the horizontal component of the displacement. So it's just, since your origin is here 0, 0, and if you look at it, the x component of the displacement will be just x here, as I show in this screen, and the y component of the displacement is just y from the point of projection to the position at time t is equal to 3 seconds. So this is asked in part A, and part B is the distance of the particle. So part B is from the point of projection from this point to this point at time 3 seconds. You are asked to find the distance here that I highlighted in the red color. Right, so now let's just try to look at the strategy or the way that we should calculate. So if you look at x direction, we know the velocity u because it's projected horizontally with 15 meters per second, so u is 15. We know time t, which is 3 seconds, so the displacement in x direction is just s is equal to ut. So since we want to differentiate between x and y, we will just use x here. So the displacement x component is just x is equal to u times t. So that is very straightforward. And now let's look at y direction. If you look at y direction, the initial velocity is 0 because it's projected horizontally, and the acceleration, if you look at it, is just equal to g, and g is vertically downwards. And for the sign convention, if we take the vertically downward as the positive, you will get our acceleration is just positive as well. So 9.8 meters per second square. And now you are asked to find the vertical component of the displacement, which is y. Now y can be found by ut plus half ad square. So because there is constant acceleration motion. So if you look at this equation, we know u, and we know t, and we also know a. So since we know 3 parameters, we can easily find y directly. So that is very straightforward problem, of course. And now, as usual, apart from what has been asked in the problem, let's also try to think what other quantities that we can find using the known parameter and the theory that we know. So if you look at in the y direction, since it is constant acceleration, the formula for the final velocity v is just u plus at. So if you look at this equation, we know the initial velocity u, we know the acceleration a, and we know the time t. So we can find the velocity at time t is equal to 3 seconds. And if you know the velocity, we can also find the average velocity v var, which is just u plus v by 2. And of course, if you know the final velocity, if you know the initial velocity and the acceleration, the distance traveled in the y direction can also be found by y squared is equal to u squared, v squared is equal to u squared plus 2as. And now if you look at the vertical displacement component of the displacement can also be found by this equation. But if you look at in order to use this equation, you need to find the final velocity v first. So final velocity can be found by this equation. So if you want to use the second method, you have to do two-step calculation. First, find v, and then second, you substitute in this equation. So it's wasting your time for two steps because you can easily find the one component of the displacement using ut plus half ad squared straight away. So of course, in the exam, you have to optimize your time. So you will use the method which will give the answer as direct as possible without wasting your time. So in this case, you will use y is equal to ut plus half at squared. And for of course, for finding the distance of the particle from the point of projection, so as I have said to you earlier, this is the point of projection, and this is the position at time t is equal to 3 seconds. So you want to find the distance d here, and this distance d, if you look at it is right angle with x and y. So it's a right angle triangle. You can use the Pythagorean theory to find that. It's very straightforward, easy. So let's try to look at that. So what is given in x direction? This is the solution, right? U is equal to 15 meters per second. In the y direction, u is equal to 0. And you are asked to find x and y in A, and in B, you are asked to find the D. So your solution in part A, x direction, if you look at the constant speed motion. So we are going to the right as the positive. And now you can see the distance in x direction is just x is equal to vt. So 15 meters per second times 3 seconds, you will get 45 meters. And now in the y direction, the motion is constant acceleration. We are taking vertically downwards as positive, so u is equal to 0, and acceleration will be equal to g, which is just 9.8 meters per second square. And g is taken as positive because we take the vertically downwards as the positive. So your vertical component of the displacement y equal to just ut plus half times at squared. So you substitute u is equal to 0, t is equal to 3 seconds, and a is equal to 9.8, and t is equal to 3 seconds. You will get the vertical component of the displacement is 44.1 meters. So you get the answer for part A. So the horizontal component of displacement is 45 meters, and the vertical component of the displacement is 44.1 meters. Right. And now for part B, we just can use the Pythagorean theory to find D. So D is just square root of x squared plus y squared. So square root of x is 45 square plus y is 44.1 square. You will get D is equal to 63.0 meter if 3 significant figures is taken. Right. So that is the solution of the problem. But apart from that, we will also look at other parameters that we can find using the knowledge and the given parameter, even though it's not asked in the problem. So if you look at in the y direction, the final velocity v can be found by u plus at. So u is 0, acceleration 9.8, time is 3 seconds. So your final velocity after 3 seconds is 29.4 meters per second. And if you are interested in, you can also find the average speed, which is just u plus v by 2. U is 0, v is 29.4 divided by 2, you will get 14.7 meters per second. And yeah, that is the solution to the problem, to find the quantities that have been asked in the problem, also some quantities that has not been asked in the problems. And now we are trying to also make sense of the average speed. So if you look at it, the average speed is around 4.7 meter per second. In my previous video, I already told you the height of 3-story building is around 10 meter. So now if you look at this, your object within 1 second, your object is traveling around, if you round it, 15 meter. So you can see here your object is so going 15 meter. So this means your object is like around 4.5 story high within 1 second. So how fast the speed of 40.7 meter per second in terms of the particle sense? So if the object has to fall at an average speed of 40.7 meter per second from the certain height, it would pass a distance that is equivalent to the height of 4.5 story building within 1 second. So it is, if you look at it, it is not very fast, not very slow as well, right? So that is the way we try to make sense of the solutions in the particle sense. So I hope you get the point. And if you notice that the way we're trying to get the solutions or explain you the example or exercise problem is, we were always trying to go beyond what has been asked in the problems, because by doing that you can analyze the problem your own way and you can link it to the practice very easily, and you will be enriched with your own thoughts to model what's happening outside when you are later in the advanced level. So those kind of foundation skills are really important for you, and that's the reason we're trying to do that part, finding some of the quantities even the problem does not ask you. There is one thing quite specific about our videos. Another thing is we are always trying to link with the practice. So in this case, average speed is 40.7 meters per second. What does it mean? It means that if your object has to fall down with that average speed within 1 second, it can pass the height of 4.5 story building or something like that. So I hope you will see the advantage of our video, and of course we will cover more examples exercise in the future videos. So stay tuned and subscribe to your channel. So with that, I will just say goodbye and see you in the next video.